Right, year 13s. At least one of you has asked about chapter 15, numerical methods for the integration. So let's start with one about the rectangle method for the slightly simpler way of doing it. 15a, question 1, 5 rectangles, find upper and lower bounds for the integral. And I'm going to do this one here, which is 1a1. On the exam, draw the graph of the function first. And I think you'll see it looks like, so I've used the graphical calculator, it looks like this. It does that, and then it does that. Why should you draw the graph? Because that's going to give you a good idea about whether you're going to get an upper or lower bound without doing both of them and checking which one is which. For 5 rectangles, we need 5 values, but because we want the upper and lower bound, we're going to get 6 values, but hopefully I'm going to explain what that means. So if we divide 0 to 5 into 1, 2, 3, 4, 5 equally spaced intervals, I could draw rectangles using the upper value in each interval. So I could draw a rectangle there, 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 and there. That would be equivalent of using x values of 1, 2, 3, 4, and 5 to find y values. All those rectangles are, well, they don't reach the curve. Using these values will give you a lower bound for the integral, whereas if instead we use the first value in each rectangle to draw the rectangle, we would get that. If instead we use 0, 1, 2, 3, and 4, we're going to get an upper bound in this case because this is a decreasing function. But by drawing the diagram, you get a sense of that. So how am I going to fill in that table? I could use either calculator, but I just happen to have it on this one already. I'm going to use the table function. The function this time is e to the minus x squared. Ignore the g of x bit, that's the way you can put 2 functions in at the same time. Start at 1, go up to 5, so in fact start at 0, and go up to 5 in steps of 1. And I don't know if you can see those values there. Those are the values here, which I'm going to put into the table. So the values are 1, 0.3678, 0.0183, 1.2 times 10 to the minus 4, 1.1 times 10 to the minus 7, clearly on the exam, draw bigger boxes so they all fit in, 1 times 10 to the minus 11. Right, how do we then get an estimate of this integral then? We add up the 5 rectangles, so for the lower bound, we add up the 5 green rectangles, which are all 1 wide. So it's going to be 1 multiplied by the height, which is going to be 0.3678 plus 1 times 0.0183 plus ... They're all going to be 1 times. So you can always do the width, which is equal, and then just add up the 1, 2, 3, 4, 5 x values. 0.3678, 0.0183 plus 1.2 times 10 to the minus 4 plus 1.1 times 10 to the minus 7 plus 1 times 10 to the minus 11, which if you think about it, we're not going to write all 11 space off decimal point. These ones are going to be relevant. the upper bound, in the same way, is going to use these 5 values for the heights of the rectangle. All the widths are the same, so this bit here is going to be the width of each rectangle, which is the interval divided by the number of rectangles. These are going to be the appropriate y values. So in this case, 1 plus 0.3678 plus 0.0183 plus 1.2 times 10 to the minus 4 plus 1.1 times 10 to the minus 7, and that's going to give us, so menu, calc, at 1 times anything's not going to make any difference, so I'm just going to add those up. 0.3678 plus 0.0183 plus 1.2 times 10 to the minus 4 plus 1.1 times 10 to the minus 7, and then any accuracy I'm going to use, these last ones are irrelevant to put in really, because they're so tiny, and I get 0.386, and we know from the shape of the graph, the green rectangles, that's the lower bound. Oh, the only difference will be to 3 sig fig. You can check if you want. It's that adding that 1, so I'm going to get 1 point, and if I do 3 sig fig, it's going to be 1.39. So when you look at the PowerPoint I'm going to send you, this is what I mean by, on a decreasing functions, these values are going to give you a lower bound, these values are going to give the upper bound, but on an increasing function, it will be swapped around. But if you draw the graph and the rectangles, it makes sense. So if you want it to be more accurate, you do more strips. And of course, if you're doing this on a spreadsheet or computation, it becomes a really efficient method because you can get as accurate as you like just by adding more strips in. Okay, that's using rectangles to get an upper and lower bound.